Today we're going to be talking about the concept of amplitude, and what we're going to do is we're going to take a look at what it looks like on a graph visually. So without further ado, let's take a look. Here we have a graph of a trig function. We can see up here that it's f of x equals sine of x. What would the amplitude of this trig function look like? Well, the first thing we're going to do is draw a line in the middle of the graph by this blue line right here. So this dotted line represents the middle of the wave. Okay, next I'm going to draw a line up to the top of the graph, and I'm going to draw a line to the bottom of that graph from the middle. The length of this red line represents the amplitude. So in this case, the length of this line is 1. Let's go ahead and take a look at another example of amplitude. Again, I'm going to draw a dotted line across the middle of the graph, or the middle of the wave. We can see that half of the wave is above the blue line, half the wave is below the blue line. Again, if we draw a red line from the center to the top of the wave, and we draw a red line from the center to the bottom of the wave, that represents the amplitude. Now what you'll notice is the length of this line is now 3. It goes from 0 up to 3, from 0 down to negative 3. If you notice the equation of this line, the 3 shows up in front of the cosine. It has nothing to do with what's inside of the parentheses, which is 2x. So keep that in mind as you move along this lesson. Focus on this number in front. Notice that that may have something to do with the length of this line, in this case being 3. Okay, for this particular example, the middle of the graph is still at 0. Now, I know what you're thinking, is it always at 0? Well, no, it's not. The middle of the wave can be somewhere else. Now, if we draw a line to the top, from the middle to the top, and then draw one from the middle to the bottom, we see that the new length is 4. From 0 to 4 is 4, and from 0 to negative 4 is 4. Now notice the number now. It's negative 4. Well, this number is still very much related to the how long this line is, meaning the amplitude. So the question is, how do we actually find it? Well, that's what we're going to find out. It's actually very simple. One more. Where's the middle of this graph at? It's not at 0 this time. If you look closely, it's actually at negative 1. Meaning that half the graph is above this line, and half of the graph is below this line. Okay, so what is the length of these lines now? Well, if we go from negative 1 up to 1, that's actually 2 blocks. If we go from negative 1 down to negative 3, that's 2. Well, notice, voila, that number still shows up in our equation, f of x equals 2 sine of x minus 1. So as it turns out, yes, the amplitude is related to this number out in front. And in fact, all you need to do, if it's negative, is just make it positive, and that will give you the amplitude. I'm going to show you a little bit more reason why that is, so let's go ahead and take a look. However, I want to give you a formal definition of amplitude. Let's make this red since we had the amplitude red. The amplitude is how far the graph spreads from the center. Okay, and even more specifically, how far the wave spreads from the center. So let me change that. And that's because really when we're talking about amplitude, we're talking about trig functions. Okay, another definition is the amplitude will always be half of the range. So for example, let's go back to this graph. Okay, so this graph ranges from negative 3 to 1, which is 4 total. So the red line, which is the amplitude, will always be half of the range. Just like in this one, the range goes from negative 4 to 4, so it's 8. Half of 8 is 4. So the amplitude will always be half of the range. Let's look at numerically what's going on with the amplitude. Now first of all, let's think about the biggest possible number that you can get for a sine graph, or for a sine function. The biggest possible number that sine can be is 1, and I will show you on the unit circle, and we'll talk about that. Okay, so here's the unit circle, and we can see that the y value of 1 is going to be the biggest y value on this entire graph, okay? Now that goes back to the fact of learning the sine at 90 degrees. That's when the hypotenuse becomes the opposite side, and in that case, it has to be equal to 1, right? This is the reason, and if you want to, you can go back and watch that lesson. But just in case you forgot, here's the visual I use. This is trig ratios at 90 degrees. Anytime you take the opposite side of this angle and divide by hypotenuse, it will always be less than 1 because the opposite's always less than hypotenuse, except when it becomes a straight 90-degree angle, the opposite side becomes the hypotenuse, and therefore sine of 90 is h over h, which is 1. And so that's why the biggest value you can get for sine is 1. Okay, the same would be, it logically makes sense that the smallest value you can get is negative 1, meaning at 270 to 3 pi over 2. So the biggest and smallest values are negative 1 and 1, which is exactly why this graph looks like this. It stretches down from negative 1 up to 1. So it makes sense then that when we plug in pi over 2, we get 1. Now, what happens if we stick a number out here, right? What if we stick a number in front of the sine, which was the pattern we were looking at here? How does that affect that? So obviously, if we stick a 3 there, it's just going to take that 1 and multiply it by 3, right? It's going to amplify it, which is why we use the word amplitude, to 3 instead of 1. Another word for that is stretch. So here we have the sine function, the sine wave going through here, and I want you to watch what happens when a turns to 3, this number out in front of sine. Okay, it will stretch all the way up to 3 at the top and negative 3 at the bottom. So it makes sense that if you start at 1 being the highest point and you multiply that highest output value by 3, you're going to get 3 on top. Now what about the bottom? Well, let's take a look at that numerically. Well, as we've already demonstrated, the smallest value you can get for sine is negative 1 by plugging in negative pi over 2, or in the same way, 3 pi over 2. Now, what if we take that and multiply it by 3? Well, we're going to get negative 3, which will give you the bottom of the graph if you put the 3 out front. So you're just amplifying that negative 1, and you're stretching it out to be negative 3, which is still 3 units away from the center of the graph. So again, if we go back and we stretch that again, making a equal to 3, we can see that what was once at negative 1 for the bottom of the graph is now at negative 3, and that will repeat, but it will never get below negative 3. So we start the lowest point at negative 1 here at negative pi over 2, and we make this a value equal to 3, and the lowest it can get is negative 3, so it makes sense. Now let's look at some other examples. What if we multiply negative 3 times sine of negative pi over 2? What will happen then? Well, if you take a negative and multiply a negative, you still get a positive back. So even if we make this front value a negative number, we're still going to get an amplitude of 3. We can see that if we go back and look at our, even if we look at the largest value of 1, if we multiply that by negative 3, we still just get negative 3 as our answer, meaning it's still 3 units away from 0. Let's take a look and see what that looks like. Okay, so I'm going to take this a equals to 3 and I'm going to drag it over to negative 3. Okay, and you're going to see a couple things happen. Let me go back and talk about this. We'll start at 1. Okay, so we can see right here at pi over 2, the biggest value is 1. Now, if we multiply that by negative 3, obviously the new value is going to come down here, right, at negative 3. And if we take our lowest value, negative 1, and multiply that by negative 3, the new y value will be positive 3. So the graph kind of flips. However, the amplitude stays the same. Okay, it's still 3 units away from the center no matter how you look at it. So again, looking at the highest value of 1, if you make your a value negative 3, then the furthest away from 0 you can get is still 3. You'll be at negative 3. And if you look at your lowest value, negative 1, and multiply that by negative 3, well, you'll still be 3 units away from the center. And one more numeric example. If you're looking at your lowest value, negative 1, and you make your a value 3, yet again, you're still just 3 units away from 0. Now, what about cosine? Well, we know that the biggest value that cosine can have is equal to 1. This goes back to the lesson of trig ratios at 0. When we see the triangle become a straight line, we see the hypotenuse becomes the adjacent side. since cosine is adjacent over hypotenuse, they become one and the same, and therefore h becomes h, hypotenuse becomes hypotenuse becomes adjacent, and so h over h is equal to 1. That's the biggest value you're going to get for cosine, and looking at the unit circle, the smallest value would be opposite that at -1. So it only makes sense that if the biggest value for cosine is 1, no matter what number we multiply that by, that's just going to be our amplitude. So if our value in front is 3, then our amplitude will be 3 because we're multiplying that by 3. We can even make that -3, and we'll still see that even if the a value is negative, the amplitude will still be -3. I'm sorry, it'll be 3. It'll be 3 units away from 0. Just to verify that, let's take a look at the cosine graph. We can see it's 1 at 0, and it's -1 at, looks like pi and negative pi. If we make a equal to 3, it stretches it out 3 units from the center. And if we make a -3, it still stretches it a units from the center. So what are we ultimately getting at? Well, no matter what the number a is here out in front, whether it's 3, 4, 5, whatever, even if it's a negative number, the amplitude will just be the absolute value of that number. It is important to note that a cannot be equal to 0 because that will turn the entire trig function into 0, and it therefore will no longer be a trig function. So let's play around with this cosine graph. Let's change it to 4, or -4. We'll still see it's 4 units away from 0. If we change it to -5, still 5 units. You can play around with this as much as you want. The amplitude is simply going to be based on this number out front, even if it's a decimal number. Okay, just a few quick examples for you. Example 1, let's say f of x is equal to 6 cosine of x. All you need to do, and I'll underline this in red, is just look at the number in front of the trig function, and that will quickly give you what the amplitude is. In this case, it's going to be 6. And one more example. I mean, it's pretty straightforward at this point. I think the large part of this lesson is understanding y. You're just multiplying those y values. Example 2, if f of x is -1/2 sine of x, it's important to understand that the amplitude can be can be a fraction, and it's always going to be positive. So it'd still be positive 1/2. The amplitude will be 1/2. And again, the way to figure that out is you just take the absolute value if it's a negative number. Okay, and you get positive 1/2, and that just means that it would stray 1/2 units from 0. Let's take a look at the graph of that. Okay, so here's sine with the a value of 0.5, and you can see in the black here it only bounces up 0.5 units from 0 and bounces down 0.5 units from 0. Okay, one more important question to ask is what happens if we change some things to the function? What if we mess around with what's inside the trig function? What if we add something to the function, what's called a vertical shift, or make any other modifications? Will it change the outcome of the amplitude if I do a bunch of stuff in these parentheses or do something else like add or subtract a number? Let's find out. Okay, so I'm back at my sine function, and I'm going to change some numbers in here. So the first thing I'm going to do is change the number right here in front of the x to 2. Now, as you can see, that did not affect the amplitude of my function, no matter what number is here. And that's because ultimately I can plug in, these are just radians, right? And we know that angles go on and on forever in either direction. That's why it's called the unit circle. You can plug in, let's just think about in terms of 2 pi, 4 pi, 6 pi, all the way up to infinity. And still, the biggest or smallest y value you're going to get is 1 or -1, depending on how big or how small the radian is. It cannot be bigger or smaller than that. So changing this number won't matter. Same thing for this number right here. Okay, that's still just going to give me some kind of radian back, and no matter what radian I plug in, I'm still either going to get the biggest or smallest y values, or is either going to be +1 or -1 on that unit circle. As a reminder, that's what this looks like. So no matter what this radian I plug in, even if I go past 2 pi or go below 0 pi, okay, the biggest y value I can get is 1, and the smallest y value I can get is -1. So changing this stuff inside won't matter. Now what about this number right here at this +0? What if I change it? Well, here's the interesting thing. All that does is just shift the graph, and we'll learn more about that later when we do function transformations. But for example, let's just stop right here. Now the center of the graph is at 2. Notice it didn't change my amplitude. My amplitude is still 1. It's 1. The top of the graph is 1 up from 2 and 1 down from 2. So none of these modifications will change this amplitude. What changes is when I change this number in front. So for example, if I drag this to 3, okay, my amplitude is now 3. It's 3 units up from the center and 3 units down from the center. Therefore, no matter what modifications I make to my sine or cosine function, the amplitude will always be the absolute value of this number out front, as long as it's not 0. That's it for this lesson of determining the amplitude of a function and understanding why. If you have any other questions about it, let me know.